15 minutes.
Great. So Russ, it's hard because I can't even see Russ now. So I don't know. I'm not talking to anybody in particular.
Well, I'll come back on so you can see me.
So this, thank you very much. This was a really interesting talk and a really interesting paper. And it has made me think a lot about sort of gaps between what the neuroscientists do and what philosophers want. And I guess I'm just going to try to play devil's advocate here, putting on my philosopher hat, because I have to say, as a neuroscientist, I feel like, well, this is of course the right way to think about things. The hard part is getting representations to play the content-bearing role that an explanatory role in the sense of providing content or meaning that that philosophers want and that most of the philosophical literature has talked about. And I guess one way of framing the worry is, we talk about models, and I think we assume that these models embody representations, that the fact that you have inductive biases that model the world therefore licenses you to talk about representations. But what philosophers would like is a way of then assigning content to those representations where that content is somehow semantically articulable, and that becomes pretty hard. So if you look at those the reconstructions of the maximal stimuli for the neurons, although you can see some familiar patterns or object-like things in them, they do not refer to anything or don't pick anything out in the world that's real. And even if you have this maximal, I don't want to say representation here, but if you have some kind of properties that are visualizable that give you the maximal activity in those neurons, there's an entire range of counterfactual images that would also give you high activity. And so it's not that that neuron is picking out that maximal image, it's picking out an entire range of properties that an image could have that would fire that neuron equally well or pretty close. And so that makes the content attribution of individual or let's say segments of this larger model really hard to determine. And I guess the question is, if that's the case, if, for instance, there's no place where you could determinately say, well, this is what the content is, or this is the thing it refers to in the world, short of essentially the very output of the system, it raises questions about what the utility is of representational talk. It gets you an explanation of what the system is doing, but not necessarily a way of talking about content. So that's the challenge, I think. So even if you buy into the model building aspect of what our brains are doing in terms of, essentially embodying inductive biases that somehow reflect the structure of the world, can you get the content stuff out of it in a way that does what philosophers want it to do? I mean, one answer is no, and philosophers just have to sort of rethink what they want of representation, but maybe there's something more to be said than that. So I think rather than sort of holding forth, I think I'd rather just, sort of ask you, have a discussion, if that's okay.
Okay, great. Yeah, so I have to admit that in going back and reading, philosophical literature, I was frustrated by what I felt like was never being able to like know what a clear criterion would be for this sort of semantic articulability thing that philosophers seem to want, right? Like, can you tell me like what is the thing I could give you that would make you happy, right? That would say, oh yes, he has so if for example if those neurons were really like the only thing they fired to was a dog space as opposed to this dog like thing, would that be sufficient?
Well, that's what uh, philosophers have wanted, right? So, I mean, there's the sort of famous Fodor example where, um, you know, you have these cow detectors. I can't remember exactly how he put it, but they also fire to horses on a dark night. And so, does it really mean cow, or does it mean cow plus horses on a dark night? And then you can sort of, uh,
So
and
I so
like
let me tell you, yeah, perfect. So let me tell you how I think about this, right? Which is basically that it actually relates very closely to things I've really been struggling with around cognitive ontologies, right? Where we as scientists, and I think philosophers, you as at least half philosopher down the middle, um, want kind of human understandable labels for things, right? You want to say this is a gray cat detector, right, or whatever, and I want to say that brain area is doing working memory, right? Um, but those are almost certainly kind of poor approximations to the stuff that's actually out in the world, right? Particularly, so let's think about how it is that you're going to go about recognizing a horse, right? You're presumably going to need to build up representations at various levels, right, so that you can represent it from different angles and all these sorts of things, right? And many, nearly all of those, and maybe even when you get to horses in the end, nearly all of those are going to be they're basically computational mathematical descriptions of the things, or redescriptions of the things out in the world. I think of them as sort of like mathematical bases, right? So edges are really easy to understand as like mathematical bases, and or templates or something like that, right? And you basically you put together a bunch of those, and that allows you to represent a much more complex set of things. Well, I mean, what we know about this is there's almost certainly, exactly as you're saying, an infinite number of ways that one could kind of rotate that space of bases and get the same answer, right? And to me, I don't see how that makes those things less about the world, right? They're different descriptions of the same world, right? And that's because the world is complex enough that low dimensional descriptions of the world are necessarily going to be sort of indeterminate, if you will, or there's necessarily going to be a large number of possible descriptions, low dimensional descriptions of the same high dimensional world, right? So my answer is philosophers need to get over
I kind of assumed that you might say that. Um, and I guess, I mean, another way of putting it is there may be nothing that's being represented short of the entire world, in a sense, by all of these elements of the system. Um, and, I think that the take home message isn't so much that philosophers have to get over it as, as philosophers have to rethink um, their notions of representation. I mean, the classic philosophical ideas of representation are, um, not points in a high dimensional space, right? Uh, they're concepts,
platonic things.
categories, or parts of things that are, discrete and, um, easily identifiable. And it looks like the at least the intermediate stages of representation. So it seems like very low level stages might be easier to attach to things, and very high level stages may be easier to attach to things that are semantically articulable or interpretable. But a lot of the stuff in the middle isn't. And then, I think it's up to the, or it's open to philosophers to say, well, those intermediate things, you may have representations in some very levels, some very high levels, because you can attribute content to them. Whereas the intermediate stuff is just stuff, it's just mechanics. You know, and then maybe we're just saying, well, that's a semantic, it's just a semantic disagreement whether or not we want to use the word representation for that. But it certainly is it pushes on many of the things that philosophers took for granted were needed in order to account for or explain. I mean, I think those are two different things. You might be able to account for stuff without explaining it, and whether that's satisfying in itself is another question. Let's see. I was interested in your comments right at the end about dynamical systems, because I thought, well, yeah, there's, there in the structurally isomorphic kind of way, then you would even say dynamical systems were structurally isomorphic, and you conceded, I mean, that dynamical systems were representational, and you agreed with that. So I think you've identified there another aspect of philosophy that sort of made opposition where, in fact, maybe there shouldn't be. I guess I'd just like to hear a little bit more about these intermediate levels of representation. There are a few questions. One is there, do you think that there's a unitary account of representational content to be had? Right, there's the causal dependency. There's sort of a causal model of representation, and you made reference to that. But that's not the only one on offer, and there are competing models of content that seem to have sweet spots for different kinds of things. And I guess one question is, do you think that there's a unitary model of content attribution, or a series of models that might, you might have to pick and choose depending on what exactly you're looking at?
I mean, the short answer is I'm not really sure, in part because I don't know that literature well enough to know all of the different things on offer. My guess is that, that the one is almost certainly going to have to pick and choose for different domains. That obviously, like, the visual domain, we would think reflects the structure of the world, right? And that thinking about, this in terms of physics might be the right way to go. Whereas other domains, there may be very different kind of organizing principles for representations, at least. And one way to think about that is like, I think about this all in terms of statistical structure, right? I think what's being coded by brains, and then what makes up these representations is a statistical description of, what ultimately a bunch of like subatomic particles are doing out in the world, making up these things that we think are like, a microphone and a monitor, but then really they're just like clouds of like fuzzy clouds of particles that happen to like come together so I can touch them, right? And my guess is, like, if you start thinking about like how do we represent like what other people are thinking, right? Obviously the rules there are going to be very different, and they're not going to be described by, like the fundamental physical cosmological constants that under which our universe came about. They're going to be described by evolutionary things. So my guess is that you're going to need a toolbox of, maybe there's an ultimately kind of unifying underlying thing. I don't need that. Um, but my guess is it's going to be challenging.
Yeah. And, just along those lines, there's a history of these different kinds of approaches sort of battling each other. And recently, people have said, wait a minute, maybe we don't actually need to come up with the one true theory. Maybe there are, maybe it's a much more heterogeneous kind of enterprise that we're talking about here. And so I think that would sit well with what you're saying. See.
Scientists are happy to live in the muck, right?
Right. I mean, it would be nice if the scientists could live in the muck, but deliver things that philosophers could work with to answer philosophical questions. And that the worry, I guess, is that the two literatures are going to become so disconnected that we're not going to be able to do that. And then it remains to be seen whether what we're going to do is just say we have I have to answer them philosophically, or we're going to say, well, these questions are actually they're wrongly formulated, and we have to redraw these questions or somehow, you know, um, reformulate questions, and hopefully in a way in which you can trace the lineage, so that you're not just leaving the deep philosophical questions unanswered, but you can see how the reformulated question is still on topic for the kind of perennial questions that philosophers talk about. I think maybe I should turn it over to somebody else, and then maybe we can circle back later if there's time.
Yep, we'd like to, well, thanks, Adina. We'd like to ask Mike Anderson. We are going, no, sorry, to Gualtiero Piccini. We are going in alphabetical order, starting with first names to share some of his thoughts. Gualtiero?
Gualtiero?
I need to connect. Am I on? Is my microphone on?
Yep.
Oh, okay, good. All right, so first, thank you to Fabrizio and Marco and anybody else who helped put this together. This is exactly what we need. I mean, we already needed it before COVID-19, meaning online webinars, online conferences, and now we need it more than ever. It's the way to go, and we need more of this, and we need I actually think we need to just replace all in-person conferences with online conferences. That's of course an extreme opinion, but anyway, thank you so much for putting this together. Ross, yeah, thanks for your talk too. I agree 100%. So I'm more interested in pushing this forward and further than finding flaws, because there aren't any flaws in what you say. The reason is I have pretty much the exact same perspective on neural representations, and I do think that philosophers have been a bit slow to appreciate them and to connect them with their own concerns about representations. And there is some work to do, and we can certainly do it. But the thing I like the most about your paper is the argument from the curse of dimensionality to the need of representations for cognition, because it's provided that the notion of representation in question is genuine, fine. I think it is. It's a solid argument that we need representations for cognition, so that we need to get past this whole like long-standing debate: are there really representations in the brain or not, or in the mind?
You just cut out.
Yeah. Piero, maybe your microphone is muted now. Just turn on. Okay, now you can speak.
Now you can hear me again.
Yeah, we lost just well 30 seconds. So what do you say?
Well, okay, sorry about that. I don't know how that happened. What I was trying to say is that my favorite part of the paper is the argument from the curse of dimensionality to the necessity of representation for cognition, because it helps us maybe, hopefully soon move beyond the old debate whether there are representations or not in the mind, in the brain. Yeah, there have to be, or cognition would be basically impossible. So let's try to understand them, and yeah, sure, understand how they relate to semantic content, what semantic content they have, what type of semantic content they have, and so forth. One question for you is about one aspect of the debate is, that you referred to actually, is this supposed contrast between dynamical approaches and representational approaches. And I always thought that was just a false contrast, because there's nothing non-dynamical about representations or about computational representational explanations or approaches, given that dynamics is just change over time, perhaps with causes that drive the change, but as opposed to kinematics, without the causes. But in any case, dynamical systems are just systems that change over time, and the formalisms are formalisms for understanding that. So there's nothing non-dynamical about thinking about how representations and computations of representations explain cognition. But at least in philosophy, there was this movement. At one point, it was led by Timothy van Gelder, that did try to define a dynamical approach as being non-representational and non-computational. And there was no argument for that. It was just, well, we don't like computational representation, so we're going to look for something else. Let's call it dynamical. And it just distorted, I think, a lot of the perceptions of some people. My question to you is, unless you disagree with what I said, I doubt it. Was this ever felt in psychology and neuroscience, this opposition between dynamic? Because you kind of at one point in your paper you say, well, see the whole history of cognitive psychology, or how like it's, we don't have to have this opposition. And I'm just curious if there was ever, if this got any traction in on that side, of things in cognitive neuroscience, cognitive psychology. Did people ever like divide things between like the representational and the dynamical approach?
Yeah. I mean, I think a great example. So, I mean, let me just say up front, I think of dynamics and representational approaches as like different lenses on the system, right? And I think you can, in that sense, you can have each lens looking at the thing at the same time. They're going to give you potentially different answers. And I think that's a great example of this comes out of work in motor neuroscience, right? Where for many years people try to come up with ideas of like, this particular neuron doing this particular thing in terms of reaching, and couldn't really get traction until people like Christian Shenoy, Mark Churchill, and others started bringing to bear dynamical analyses of neural data, and suddenly showed, hey, look, if we analyze the data in this particular way, we can actually get much better traction on what the animal, how they're reaching their hand, right? Whereas in the visual system, those types of analyses haven't really come to the fore, because you can actually do pretty well just like doing things like I showed you, right? Kind of treating things in a very kind of representational sort of way. So there certainly are examples where the dynamic lens has turned out to be more useful for predicting behavior and explaining what neurons are doing. But I think that a lot of, that right now in neuroscience, there's a lot of people who work very fluidly kind of between the two and really don't think of dynamics as being different from representation. I mean, I think that I'm guessing Mike will have something to say about this, but I think that there was some things conflated in the approaches like Van Gelder's approach, right? And this kind of older dynamical system stuff. Whereas if you really look at the organism as a whole and say, I just want to explain, how it's going to move itself with a set of differential equations, right? Then you can maybe think of that as non-representational, right? But that's only because you're doing it at a level that you don't have to think about how it's actually being done, right? Whereas if you go down into the system, at some point, you're going to need to start breaking things up. And I think representations are going to come in, even if they're being described in terms of dynamical systems. That dynamical system, whatever the place in state space, is representing some particular aspect of what the organism is doing.
Yeah, thanks. Changing topic. Have you ever run across the good regulator theorem?
Good.
So there is this.
I've heard of it, but I can't remember what it is.
No, that's fine. There's this old paper from the early 70s in which the authors show that under plausible assumptions that very plausibly would apply to nervous systems, in order to control a system effectively, they say optimally at various points, but even any close approximation, you need to have a internal model that's largely isomorphic, to the stuff that you're controlling. So in the case of the nervous system, it would be the organism and the environment, the body and the external environment. You'd have to have a largely isomorphic model in order to successfully control the system. So it's not the argument you gave, but it seems to me that it's closely related, and it's another consideration that really should have been more prominent, it seems to me, in this debate. That's why I say we need this kind of consideration to try to move past this resistance to the idea of representations and processing representations.
Thanks. That's a paper that it sounds like I definitely need to read and talk about when I revise my.
It's a good one. It's a good thing to be aware of. It's been discussed a little bit by philosophers in recent years, but I'm surprised that it took so long. I don't remember reading it or hearing about it when I went to school. I went to school in the 90s and the early 2000s, and I never heard about this. And now, more recently, I ran into it. So it's another thing that can maybe reinforce your argument. And another thing that can help maybe a little bit is be even more explicit than Shay about what counts as a representation. One thing, one way that I think has become increasingly popular is this idea of a structural representation, and sometimes it's characterized as having four elements. One, that there is this partial isomorphism with the variables or the entities that are the target of the system, the targets of representation. Two, there's a causal connection with such target. Three, it's possible for these internal states, the putative representations, to be decoupled from their target, meaning that they're active even in the absence of the target and the causal connection with the target. Think of, let's say, the blind spot. The representation of what's in the blind spot. You can still have active representations even though there's no input coming at that moment from the blind spot. And fourth, a role in action control. And clearly, the stuff that you're talking about, fits these four criteria. So that would be possibly an even more explicit and precise way to say, yeah, if this is what you mean by representation, if this fits the job description challenge, the Bill Ramsey job description challenge, Yeah, we've got that in the brain all over the place. And then finally, part responding to what Adina says, I think that it helps to distinguish two notions of content. This idea goes back to Paul Grice, who distinguished between natural meaning and non-natural meaning. Natural meaning is the meaning of things like dark clouds mean rain or smoke means fire. There is some sort of correlation or information carrying, and if that's what you mean by content, if that's the notion of content you have, there's a vast philosophical literature that you refer to, like Karen Neander is a good representative of that literature. She has a recent book on this, and Nick Shea is another one. Of like careful accounts of this natural content, a natural semantic content, and neural representations surely fit that bill. They carry that kind of content. Exactly. It might be indeterminate. There might be intermediate layers where the content is some kind of structural feature of the stimulus that doesn't correspond to anything observable on the surface of the stimulus, but it might the content carried, the information carried might be some partial similarity between that stimulus and a bunch of other stimuli, and that's fine too. That's still a kind of natural meaning. There's also non-natural meaning. That's the meaning of things like language, sentences in a language that's not necessarily correlated with the stimulus. That's a little more complicated, but it would require a different story and maybe specialized neural systems that deal with it, and that's a story worth exploring, thinking about down the line.
Cool. Well, thanks. This is I'm going to email you for follow-up because this has been really helpful.
Yeah, I would love to. I'd love to continue this over email. Yeah, thank you.
Marco, turn on your microphone. Marco. Okay, we can ask Mike Anderson. Can you also please turn on your video?
Right. Am I on now?
Yeah.
Yep. Perfect. Well, so as expected and feared, my colleagues have honed in on some of the very things hoping to discuss. That's a good thing. Let me also thank Russ for this paper. It's extremely clear, and because of that, it serves as a nice sort of whetstone on which to grind various philosophical axes. Doing that over the coming months. Let me start with one of the things that Dina brought up, but let me just approach it from a slightly different angle. The representations that are sort of provably there, right? These kind of weird texture gradients and quasi-dog pictures and things like this. Those are not introspectively available features of our experience. So I guess and that's interesting. I mean, it's really interesting. So I guess what I'm wondering is if you have thoughts about whether or to what degree this drives a wedge between neuroscience and psychology. So Dina was talking about what philosophers want from representations, but psychologists want things as well. And one of the things they've tended to want is the ability to explain features of experience in terms of representation. And this doesn't seem to help with that project at all.
Interesting. Yeah, I mean, I think certainly not all psychologists require that, right? And the kind of psychologist that I think of myself as, mostly focuses on trying to understand psychological mechanisms that also aren't necessarily introspectable, something like cognitive control or things like that. Obviously they hit up against things that are introspectable, but a lot of them aren't. So there may be some psychologists, I think you're right, that is the fundamental thing that differs here, is that this is all about kind of subpersonal stuff, right? And for me, that's fine. But I do realize that there are some people for whom, at least some concepts of representation, they want that out of it. And I think that that's just a fundamental difference between this kind of theory and those kind of theories. I don't think you're going to get that out of this kind of theory of representation. I think it's still a theory of representation, but I can see how somebody who requires that personal level stuff from their theory of representation is not going to get that out of this.
Yeah, so then just maybe a little bit more broadly speaking, do you think that we need to rethink the nature of cognitive neuroscience in light of these results, right? This doesn't look like the vision of cognitive neuroscience with which that field began.
Well, as you know, I've been arguing for a while that we need to rethink how cognitive neuroscience is getting done. But I think in particular, I mean, I kind of mentioned this parenthetically, I've been really struggling because, I've been thinking a long time about cognitive ontologies and like, what are the functions that we're trying to map onto brain systems, right? And this is a real challenge to that, right? So if you try to think about what have we learned about the visual system from the Dan Yeomans work, right? We know that layer pool 6 in this convolutional neural network is most predictive of activity in area PIT in the monkey cortex, right? What have we learned about, we can predict that activity really well. So presumably we've learned something, but beyond a description of all the parameters in that particular layer and its input and output relationships, what have we learned about the function of what that area does? I don't know. And I mean, this is something I've been struggling with. I gave a talk at this Wash U last year about this, which is sort of starting to think about it, and I still don't have a good answer yet, is what does the ontology of cognitive functions look like in light of this kind of thinking? And I think it's not going to be things like working memory and self-control and stuff like that. It's going to be in a different language, in a computational kind of language. But I don't know that we even know what the right, I don't know. I don't think we know what that computational language is going to look like yet.
Yeah, but as you know, I'm interested in those kinds of questions as well, and this does seem to bring that to the fore quite forcefully. Along these same lines, I don't know if you have any thoughts on this, and I'm just starting to think about this in light of this paper and some others that have come out recently on deep learning. Psychology, I feel like it's more dominated than you seem to indicate by kind of introspectionism still, right? These kind of breakdowns of experience into bits, and that doesn't map at all onto what the neuroscience is telling us. So I think cognitive psych might be in more trouble than you think it is. Right. But I'm also wondering if you've thought about ecological psychology along these lines, because ecological psychology was never interested so much in breakdowns of experience, but interested in what kind of information is available in the perceptual stream. And it appears to me, and I'd have to think this through in a systematic way, but that the kind of weird sorts of features that get extracted by neural nets look a lot like the kind of things Gibson was talking about with texture gradients and things like that. And so I'm wondering if you feel like this is maybe a win for ecological psychology over cognitive psychology.
Yeah, I think it's certainly a win for thinking more about the nature of the natural environment that humans find themselves in and the nature of their apparatus that operates on that environment. So I think that in that sense, and I'm not alone in thinking that a lot of people have become, I mean, it's been clear in neuroscience for a while that the answers that you get about how visual cortex works from showing animals just individual images turns out to be very different than the answer you get when you show them dynamic things, right? And I think in cognitive neuroscience, people are now coming around to this idea of using naturalistic stimuli, trying to understand, videos, audio recordings, whatever, trying to understand kind of more complex patterns that emerge from that. So, and I think that this helps push even farther in that direction in thinking, thinking much more about how it is that that the naturalistic environment drives the structure of information processing. I think we've come at it, cognitive psychology has come at it from this very kind of top-down computational sort of computational sort of thinking, right? That there's these processes like memory and, syntax and things like that, that have been really divorced from the outside world, right? And we've become interested in this in part because of work that we've been doing that shows that, like, people in cognitive psychology think they're studying cognitive control or, something that's related to like self-regulation. Turns out to be totally unpredictive of actual real world control and self-regulation, right? And so that's been really causing me to rethink the degree to which, like, the things that we think we're studying are really, it's almost like a jingle fallacy sort of thing, right? If we call it control, it must be the same thing, right? But the data is showing that it really isn't, at least if you look at like predictive validity.
Yeah, thank you. So if there is a weakness to this paper, so I'm switching gears a little bit, it's in this notion of decoupleability. That video you showed of the Japanese patient, fascinating. That needs to go in the paper. That's a great example, because that one, unlike the other examples you have, really brings back the notion of induced experience, right? Which in the animal literature is always going to be a question. So that was fantastic. That being said, normally when we think of decoupleability, we think of the capacity of the system to engender or create representation in the absence of the stimulus. But in the particular examples that you raise, you're just kind of faking the stimulus. It's not in the absence of the stimulus, right? You're just intervening in the causal chain at a particular point. So I'm not certain that's really decoupleability. I don't know if you're
yeah, thanks. I mean, I've been a bit concerned about the degree to which those data would really kind of, support that sort of claim. So what about, so like there's all this interesting stuff with deep neural networks, right? Where you can basically like dream up new, like you basically turn the network on and have it like generate new images, right? Of things it has never seen. Like, you've probably seen these like style generators where you have it like, dream up images that look like a Van Gogh image having been trained on Van Gogh images, right? And obviously we can do visual imagery in the absence of, we don't know what's going on in lower level visual systems when people do visual imagery, though we know that those systems get engaged when they do imagery. So, so there's at least a loose link. So do you think that, for example, that kind of like, image generation stuff, at least with the artificial networks, addresses this decoupleability?
I've never thought about it, so I don't know. But let me just say provisionally no for the following reason, which is that normally when people talk about decoupleability, as I say, they mean the capacity for the representation to play a role in the cognitive system in the absence of its stimulus, right? So that could be imagination, it could be memory, it could be various other kinds of things. So it has a natural in the context of the operation of the system. And none of the examples, even including coming up with a novel Van Gogh, is playing the role of, is playing a particular cognitive role within the system in the absence of its stimulation. That's like that's an extrapolation, which is interesting and it's cool that's possible. But it's not the representation playing a particular kind of functional role in the cognitive.
So is there can you imagine, I'm trying to figure out what the criteria would be for playing that role, right? Can you imagine an artificial neural network system ever achieving that criterion?
Yeah, maybe. I mean, so I'm thinking now of like Chris Weiss and stuff with Spawn. And so I can easily imagine setting up Spawn in such a way that it imagines the numbers and then it does addition in the absence of the actual stimulation. I don't know if he can do this with the current system, but given the way that system runs, I expect that it would be possible to do something.
So if we were to example, hook a drawing arm onto the neural network that dreams up the Van Gogh and have it draw the Van Gogh, does that count then? That shouldn't be that. That seems like the easy part, right?
Right. Yeah. Maybe. Yeah. Interesting.
I think Adina has her hand up.
Dina,
Yeah, just I think along these lines, one of the things that struck me about this decoupleability discussion is that the way in which the representations are supposed to be decoupled in the kinds of things I think, Mike, that you're thinking about is same representation is supposed to be shuttled around and used here and there, right? It's supposed to be activated by vision, but then it could be like used in memory. And so that's like, that's a very digital kind of notion of representation. Whereas the representations that, you know, we're talking about in the neural networks, you don't get to move your brain area somewhere else, right? It's not that same population of neurons that's being used in a different way in the system. And so I'm wondering whether, you know, the classic stuff is really thinking about digital representations as these kind of fungible things. It seems like the kind of representation we're talking about here, I don't know whether it's digital or analog or whether we just don't even have the right kind of categories, but it's not, they're not portable in the same kind of way. There's not like a token and a type. And so
they are portable in one way, right? If I take that artificial neural network and I record all of the weights and then go put it on a new computer with all those same weights, then I have transported that representation.
right.
Presumably, if you could engineer, well, I guess here's a question, right?
Transported that representation in virtue of transporting the entire model. That's why I was talking earlier about the holistic versus sort of piecemeal view, right? You take that representation, you stick it in a different network, you no longer have that representation. So it's
depending on your definition of different network.
Yeah, well, I mean, you know, you change the previous layers or the output layers that it's getting information from or projecting to, and it no longer has the identity that it had. And so it just strikes me as a very different notion of representation than most of the philosophical literature has dealt with.
I can buy that.
Mike, I don't know whether you have something to say about it. This was another thing I was going to ask about the sort of digital versus analog. In a sense, it's not clear to me, even though neurons are in some sense digital. It's not clear to me in what sense we can think of this version of representation as being digital. And moreover, it seems to me that because of representational geometry and thinking about things as sort of these spaces that have similarity metrics on them, that we may be moving back towards an analog notion of representation for cognition. So
why does that matter?
Well, I think that a lot of the implications about what you can expect representations to do change, right? One of them is the portability or the fungibility, right? You're not with a digital representation, you know, you can move your symbol around or your bits around and it can play the same role in different places. It's not clear to me that you can ask that of this kind of representation.
Yes, I'm not convinced that, well, I mean, it depends on what the constraints are on the digital thing, right? Because I think in the example I gave, if you can move, assuming that the architecture is exactly the same, you can move the weights from one to the other and you get the same thing, right? So it's just a question of like, what are the constraints on the move?
But you don't get, I mean, you can move the weights of the entire system from one to the other. Like you can reproduce your system and your model, right? But you can't take the neuron that has the little, you know, sort of doggy face profile and even replicate its incoming weights and outcoming weights in the context of a different system and have it represent that same thing.
Right. Yeah, that's fair.
Yeah, one way to think about this contrast is going back to the computational literature is in terms of reproducing an object, right, as an object-oriented programming, and using that same object in different contexts. And that's a sort of a digital thing. You can move it around and say you've got a car object, and so you're representing car in all these different systems, and they're being moved around because they have the same internal structure. And that's quite different from what you're getting in these neural nets, where the identity of the representation depends on the entire configuration of the system. And so it can't be moved in that same sense. And yeah, that's a really interesting contrast. And I think Marco wanted to move up to the audience at this point. So.
Okay, so yeah, we can move to the attendee because we've already seen two questions. One from Carrie. Marco, can you give Carrie the...
Well, yeah, of course. Thanks, Carrie, for being here again. And just a reminder for everybody, if you want to ask questions, book them now by pressing the button you're seeing with the hand. Sorry. Please, Carrie.
Hello? Can you?
Yeah, we can hear.
Okay. Okay, so yeah, I'm not seeing, but anyway, so yeah, thanks to everybody, Russ and Adina and Mike and Altiero, and nice to hear from you all, and thanks again for the session. So yeah, I had some of the concerns that were already raised. So let me just go in a somewhat different direction, although I think it brings up some of the same sorts of worries. So it seems like it seems like on this picture you would have representation all the way down, so to speak, right? So anything that has two neurons to knock together will have representations, and maybe not even neurons. I mean, I'm not even sure what that adds. I mean, that's you know, a question is, you know, do you need neurons for this notion of representation? Or is it something that, you know, some sort of function, something that happens between whatever inputs the entity gets and whatever outputs it has? There's some sort of transformation that goes on, and it can be done by neurons, but it doesn't have to be. So you might go that way. So that's sort of one part question is, you know, how far down does this go? And if you're, you know, I don't know if you're stopping at whatever has neurons or not. But also, from a, you could also put it the other direction. It's like, well, we're just going to be associationist all the way up. Anything that is able to transform these inputs into a particular output with the appropriate dimensionality reduction, you know, that's going to be a representation, and that's fine. You know, whether it's in a, you know, a bacterium or a honeybee or a macaque or a human or whatever. And in which case, if you go that way, which is, you know, again, I mean, if you're talking about a notion of representation that may not map onto the kind of standard philosophical one, I mean, that's fine. I'm not arguing against that. But if that sort of notion of representation and you're going that way, then one would want an explanation of what is it that makes what part of the model that you're giving would help explain the difference between whatever representations a human has and whatever representations some other less well endowed creature might have. And in that case, you might just say, well, you know, as far as what's going on internally, there really isn't any difference. And the real difference is to go with the ecological people that Mike was talking about. Say, you know, really that difference is going to be given by the types of behavior that will be taken as evidence of what's going on. In our case, verbal behavior, we have very articulate, you know, vocal systems. Other creatures don't have that, but they have other ways of you know, communicating very complex things. So I'm just wondering, you know, in terms of, you know, how far down does it go? You know, where does it start?
Yep.
And then, in the reverse direction, if you want to just be, my notion is a more associationist one than the philosophers like. Too bad for the philosophers. It's a perfectly good one. And we can build up what we need for maybe a more philosophically acceptable notion from these basic elements by, I don't know, tacking on, culture or something like that.
Cool. Oh, thanks. These are great questions. So I guess I wouldn't buy that this requires neurons. Like I think that the stuff I showed you from Chris Ola's work of the doggy looking faces in a artificial neural network, I think those count as representations in the context of the particular problem that system is solving, which is the object recognition problem, right? And the fact that it can do so well, says that it must have learned the statistical structure of the particular millions of images that it has been trained on, along with having as I mentioned, having the architecture of the system embodying constraints like the convolutional architecture and the hierarchical nature that that reflect the constraints of the natural world, right? So I think that, ultimately, I think that, that these are all sort of results of statistical learning of various sorts. So it's associationism I agree that it's associationism in a way, though it's not I think when people think of associationism, they often think of basically what I was referring to as model-based or model-free learning, right? Which is basically, I'm going to go out in the world with no preconceptions about how the world works, and I'm going to start recording associations. That's clearly not how we work, and that recursive dimensionality argument shows that kind of association just won't work. That you have to come at the world with constraints, with inductive biases, and we have different types of learning we can apply. We have sometimes we just learn statistical structure from the bottom up through unsupervised learning. Sometimes we learn through feedback. Sometimes we learn through teaching. We learn through sort of sort of prediction, kind of self-supervision, right? We predict what's going to happen, and then we see if it happens, and we change our predictions based on that. So I guess, I would be comfortable with calling this a sort of a sophisticated neo-associationism where the constraints on the system are built in both by evolution and by by the nature of our learning mechanisms. And in terms of how I would differentiate between humans and other creatures, either natural or artificial, I think you're exactly right that it's a combination of what are the environments we live in, what are the things we need to do in those environments, what are the types of behaviors we exhibit, and then what are the neural mechanisms that we have that allow us to do those things with varying levels, right? Language is obviously something that humans have that others don't have, that allows us to solve problems in the environment that other organisms can't solve. And obviously evolution selected for that for a reason. So I think that's the right way to think about what those differences are.
Okay.
Thanks, Karen, and thanks, Russ. Sorry, I'm moving to the next questions because there are quite a few. So we'll try to have as many people speaking as possible. We'd like to collect 3 questions at once. Lara Catherine, Wojciech Mamak, and Rodrigo Diaz. Please, I'm unmuting you, Lara. Just very quick questions.
Okay, can you hear me?
Yes.
Okay, great. I'll make it quick, and I hope this is not repetitive because the previous question touched on some similar issues, but I have 2. Great paper, thank you. So I guess my question is, when does the representation start, or what qualifies as a representation, insofar as do the representations exist at every level, like at the level of the neuron or higher up the processing stream? So would edge detectors be considered a representation, or can the content at each stage or level be considered a representation? Because philosophers I'm a PhD student in neuroscience with a BA in philosophy. So philosophers might say that there is something sort of fundamentally different about representations, and that they must represent something as something else. And if they are not doing some explanatory work in that way, it's not a representation. So would you consider that representations sort of doing work at every level, or there is some point in the brain where the information becomes a representation? That's my first.
That's a good question. So I guess I would, I'm willing to like leave receptors out, right? The first layer of receptors in the retina maybe aren't representing the world, but once you get beyond that and you start having neural networks that apply evolved dimensionality reduction to their inputs, I'm comfortable calling those representations.
Okay. The one other quick question is that you said that representations must exist for an organism to behave intelligently in the world. So, but can't you have have intelligence without representation? So you might think that behavior could be explained by cognition, but perhaps not, right? So Rodney Brooks robots might be an example of where you have flexible behavior without representation via
I don't buy that.
associative learning.
No, I don't buy that his systems don't have representation.
Right.
Okay.
Thank you very much. Yeah.
Thank you. Wojciech Mamak?
Yeah, hello. Can I be heard?
Yes.
Right. Thanks for the talk once again. I have two quick questions. One, I'm wondering, what you said about cognitive ontologies. I'm wondering whether what you said can be illuminate how we can differentiate the cognitive processes. What I'm mostly interested in is, do you have an opinion on what you said gives an indication or on the inferential account of cognition or perception? Would you be sympathetic to that kind of account? So would you say that there's
I'm not exactly sure what you mean by an inferential account.
So the idea basically that you can differentiate inference from association, for instance, in a cognitive system, based on the account.
I don't buy that those are. I think that these are all functions of a statistical learning apparatus. That these things infer. They build representations. They use those representations to infer. I think that a lot of the work in probabilistic analysis of neural systems is showing this to be a really useful lens, at least on how brains work. So I don't buy the need to kind of separate those.
Okay, right. Thank you.
Maybe we got time just for a last question, Marco, right? And then...
Yeah, but we have a plan for the unasked questions. So Rodrigo, be the last one.
Okay, thank you very much. Can you hear me?
Yeah.
Okay, so this is related to what Adina Roskis was saying before, questioning whether these are representations or not, or whether representations in the interesting sense. And I wonder whether we could grant that these patterns of neural activity are representations, at least non-conceptual representations, maybe, as long as they, like properties of the stimuli predict these patterns of neural activity. So it seems like this pattern of neural activity, or at least they are representing these low-level properties. But maybe even they are actually conceptual representations as long as they are associated with a specific label. So they are specific with cat, or so they will be not only representing the low-level properties, but representing this as a cat. So they will be conceptual. And then, so this could be actually representations and maybe conceptual representations. And then the interesting question is whether these can be combined or used in other processes. So then the claim that will be questionable is not whether these are representations, or these are real representations, but whether these are the basis of intelligent behavior, as I think it was said in some part of this.
So yeah, thank you. So I guess the challenge for me is, where do you draw the line, right? You might imagine that a visual edge in a particular place in space, that's a conceptual description, right? There's lots of patterns of visual input that could give rise to the same apparent visual line in space, but that's going to allow higher order behavior to happen. But I don't think that's what people are thinking of, right? They're thinking of like cats or love or some sort of like very high level conceptual thing. But I don't see a fundamental line between like an edge in a place in terms of like the conceptualization of representation that I'm thinking of. I don't see a fundamental line between like an edge in a particular place in space and something that looks like a cat.